I rewrote the Dinero.js core package from TypeScript to Rescript in just 14 hours using AI. In this video, I'm going to go over the technique I used to achieve this result while retaining 99% of the test code coverage. I'll also go over some of the challenges I faced and how I overcame them, and I'll also reflect a little bit on how I felt about letting AI write so much code for me. I'm Nathan Tranquilla. I've been a web dev for 14 years. Let's get into it. Rescript claims to be fast for both incremental and clean builds. But until this project, there was not much hard data on just how much faster Rescript builds are as compared to TypeScript builds. So I started looking around for a project that is written in TypeScript that I could manageably rewrite to Rescript for the sake of benchmarking. To make this manageable, I was looking for a code base at around 50 to 100 files. So with the help of AI, I identified Dinero.js, specifically its core package, which came in at around 70 files. So this was large enough to provide meaningful benchmarking data, but small enough to be accomplished within a reasonable time frame. I was also looking for a library with great test coverage. Since Rescript generates JavaScript as its output, my strategy was just to take the existing test suite and point it at the Rescript generated JavaScript code. So I cloned the Dinero.js repo and I copied the core package out of its mono repo setting here into a repo of my own creation in this top level folder. And alongside it, I created a Rescript folder where I would accomplish the rewrite. Next, I had to figure out an incremental strategy for porting over the Dinero.js core files to the Rescript side with full test coverage. I used the module name mapper setting in the jest configs to rewrite the import statements of the jest files to point to the corresponding Rescript source folder. So I created a little helper function with the help of AI to add those mappings for the Rescript files that have been already ported. And by intentionally breaking the source code on the Rescript side, I was able to determine that this little method was working. For this strategy to work, I had to mirror the directory structure as closely as possible on the Rescript side and output the JavaScript code alongside the Rescript source. This made it easy to retarget the just test import statements to the corresponding Rescript generated JavaScript source code. With the strategy firmly in place for reusing the existing jest test suite, I needed to identify which files should be moved first. So I used AI to scan my codebase, identify the dependency structure, and suggest which files should be moved first and which should follow. So AI excels at this kind of task, so it quickly identified which files should be moved for me first, and it was these type files. So with my strategy complete, it was time for me to start porting over files from TypeScript to Rescript. With my strategy for success firmly established, I felt comfortable at this point letting AI do the port from TypeScript to Rescript. So starting with the files that had no dependencies, I started asking AI to move the files over one by one. This gave me a chance to see if the strategy was working, to provide feedback, to iterate, and generally to establish a context with AI for the rest of the rewrite. The first challenge I faced was handling Rescript-specific refactoring. For example, array access in the Dinero source. So deconstructing an array like this might result in one or more of the variables being undefined. And since Rescript is a very safe language, array access is always done through the option type. So for the sake of this benchmark, I settled on just using the option get or throw. This was as safe as the existing Dinero source code. Another example of Rescript-specific refactoring included handling of union types in the function APIs. This made getting 100% test coverage challenging without modifying the existing jest code. So in Rescript, I had to make a helper function that would perform a runtime check on a type and convert it to a polymorphic variant. So unfortunately, converting the Rescript function API from what was in TypeScript a union of types to a polymorphic variant meant dropping some test coverage. Fortunately, these functions were internal, which meant only dropping a total of 4 tests. The other challenge I faced was module name conflicts. This is where the strategy with the module name mapper started to show some flaws. TypeScript doesn't use a module system in the same way, so having duplicate file names was permissible so long as they were located in different folders. In Rescript, however, this is not the case. Rescript file names define the module name itself, so regardless of where the code is located in the source. This complicated my module name mapper strategy, and at this point I had to switch from a less dynamic to a more manual approach to these mappings. It felt uncomfortable letting AI do so much of the coding for me, but I'm still problem solving, just at a higher level and a lot faster. What I really enjoyed about this project was setting up the strategy and the constraints in which I knew AI would succeed at the rewrite. So within these constraints, it felt permissible to let AI iterate and struggle until the tests were satisfied. With AI doing the grunt work, my energy was freed for the most important parts, like deciding on how to handle unsafe array access, or how to convert typed unions to polymorphic variants, or handling module name conflicts. Of the 14-hour rewrite, I spent maybe a third of that getting the strategy right with the testing. So by my math, that's about 9 hours of AI porting, or about 7 files per hour, or a little over one file every 10 minutes. That seems like an acceleration to me, so I'm overall happy with the result. If you want to see the benchmark results, then check out this video.